All right, so in this video, I'll cover 3.2, zeros of polynomial functions. First one, you need to understand the meaning of three terminologies: the solutions, okay, and then root, okay, and then zero. Right. So actually, three terminologies have the same meaning. Okay, so solution, we use a solution. What does that mean? Solution is the value of x satisfying the equation, right? So we use that terminology in the equation. Quadratic, for example, quadratic equations. The solve the equation means to find the solution. It means that the solution makes the equation to be true, right? The root and zero, we use those two terminologies in our function. Root means the we use this one as a function. So root is the x coordinate, the value of x coordinate that return the function to zero. Okay, so for example, for given for f of x, f of 1 equals 0, that means 1 is root. Okay, so actually the root is x coordinate of x intercept. Okay, so you need to understand the meaning of the x coordinate, x intercept in the function. So actually in our equation, so solution of equation must be x coordinate of x intercept in our associate function. Okay, so we use the solution in our equation, and then we use root and zero in a function. But zero, we use the zero, especially we use zero, the terminology in the polynomial function. So chapter 3, section 3.2, we're gonna talk about the polynomial function, and then goal is to find out zeros of polynomial functions. Okay, so 3.2. So zero polynomial function. Okay, so we use the capital letter P instead of the lowercase letter f. Okay, to when we denote function, polynomial function. Okay, so P of x means the polynomial function. Okay, keep in mind this. So the objective, I told you, the big objective is to find zeros of polynomial function, right? But yeah, we know how to find out the zeros of quadratic function, right? Because we just solved the quadratic equations. We know how to solve the quadratic equation, right? Just simply use the quadratic formula. It's not a big deal. But what if, degree of the polynomial is greater than 2? Okay, 4th degree or 5th degree or 6th degree, 11th degree polynomial. How can you find out zeros? That's the goal. Okay, so to do that, we need to learn the ordinary division, syntactic division, and the 4 theorems. Okay, so it's an ordinary division. So what does that mean? Ordinary division, syntactic division. These are a tool to divide the polynomial by polynomial. Okay, so to build up the strategy for solving, for finding zeros of polynomial function, we're gonna adopt the theorems relating to the division. Okay, polynomial, division by polynomial. Okay, so first one, we should know how to divide polynomial by polynomial, right? So the first method is ordinary division. Second method is syntactic division. So the third one, then we gonna see the remainder theorems. Okay. So Therefore, is the factor theorem. Okay, and then the fundamental theorem of algebra. So I'm gonna briefly introduce that theorem. But this is a really big important theorem in the algebra. But we'll just introduce this. Okay. Fundamental theorem of algebra. And then last one is the rational zero theorems. Okay. So yeah, once we practically the last objective is theorem is really useful. Okay, so we're gonna use this one, rational zero theorems, and then definitely we're gonna use this theorem to find out the zeros of polynomial. Okay, so give me a second. Let's see. Okay, all right. So let's see. All right, so the order division. Okay, what's this? Start from this. I want to divide the polynomial, the p of x. Okay, so the first order division. This is 2x cubed minus 5x squared, and then plus 4x minus 6. Okay, so now I want to divide the p of x by x minus 3. Okay, right. So then what are you gonna do? So then similarly what we do, we divide number by number. Okay, we just write down the dividend. Now this is gonna be dividend, right? This is called dividend, and then divisor is gonna be x minus 3. Okay, so can you understand that? So what? So right here, when you divide, for example, 13 there, I want to divide 13 by 2. Okay, then we need to figure out the factor, right? I mean, figure out factor of what? You need to figure out a number to get 13 from 2, right? So, but we cannot get the 13 by multiplying some number by 2, right? So, but we'll find out the closest number to 13, which is 6. 2 times 6 is 12, right? Okay. And now then we subtract 12 by 12 from 13, we're going to get 1. So now, then we repeat this process until we get a number which is less than that divisor, right? So this is a remainder, right? That's called the quotient. Let me say Q. Okay. And the 13 is called the what? Dividend, right? And this is the divisor, right? Okay. So now then what? We could express dividend in terms of the divisor quotient remainder, right? Divisor times quotient and the plus remainder, right? Okay. So now we wanna express the okay, we're gonna adopt this division into the polynomial. Okay, so that I want to express the polynomial function in terms of divisor and the quotient remainder. Okay, that's what I introduced the previous video. Then so now back to here. Then what we want to find out the term to get the 2x cubed from x. Okay, so that's gonna be what? 2 times x squared, right? So 2 times x squared. So x times 2 times, now, okay, you see x times 2x squared is 2x cubed, right? So we multiply x minus 3 by 2x squared, so which is 2x cubed, and the minus 6 times x squared. And then we subtract. Okay, so these two guys gone, right? And then minus 5x squared minus 6x squared, that's going to be x squared. And then just copy down for x and minus 6. So we repeat this process until we get the polynomial whose degree is less than degree of divisor. Look at the degree of divisor, 1. So we repeat this process until we get the number constant, because the degree of constant is 0. Okay. So now see the minus 5x squared. To get the minus 5x squared from x, we need to multiply x by minus 5x. So we got not minus 5x, sorry. It should be, we have to look at x squared, right? But to get the x squared from x, we need x. So x squared. X times x is x squared. Negative 3 times x is negative 3x. Subtract. It's gone. So we got negative x minus 6, right? And then minus 1. So which is see, yeah. So we got the minus x. Okay. This should be plus, right? Minus 6. So this should be 7, right? It's typo. Okay, so we need let's see, x not minus 1, actually 7, right? So we got positive 7x, sorry. And then negative 21, right? We subtract. Okay, so we're gonna 7x minus 7x is 0, and then minus 6 minus 21, that's the what? 15, right? Okay, so now finally we got the constant. So this constant, the degree of the constant is what? I told you this is 0, right? So degree of constant 0, degree of divisor is 1. Yeah, so we can get 15 by multiplying x by a number, right? A term. So this is remainder. Okay. All right, so 2x squared plus x plus 7, that's gonna be what? Remainder, right? Sorry, quotient. Okay. So now the dividend, which is a polynomial function, p of x, can be expressed by in terms of the divisor, x minus 3. This is divisor. And then quotient, let me just say q of x. Okay, so q of x means the 2x squared plus x plus 7 quotient. And the plus remainder, r. So here r is 15. Okay, so this is how to divide the polynomial by polynomial. Okay, so using it by the ordinary division. Like this is ordinary division. So I wanna to divide polynomial p of x by x minus 3 using syntactic division. Okay, so in the syntactic division, we just write down the coefficient of each term in the polynomial function. Okay, so it's 2, and then negative 5, and then 4, and then minus 6. Okay, so now then we write the line like this. Okay, so now then let's see where the number comes from. Let's see, 2, negative 5, 4, negative 6. These number come from the coefficient of each term in the polynomial function. See that 2, negative 5, and 4, and negative 6, right? Okay, and then we just write down the number making divisor to be 0, which is 3. Okay, so we wanna divide the polynomial function by the divisor x minus 3. And when x is 3, we're gonna get 0 in the divisor, right? So we put that number, and then just copy down 2, first number, and then we multiply 3 by 2. Okay, and then write down the result into the second column, in the second row, which is 6 right here. And then we add those two numbers, negative 5 and 6. Okay. Give me a second. All right, so now we add those two number, okay? So which is 1, right? And then we repeat this process. 3 times 1, which is 3, adding them up. I mean, add the numbers in the column, which is 7. It's 3 times 7, 21, which is 15, okay? So that's the last number going to be remainder. The 217 means the coefficient of second degree polynomial, okay? So why second degree? Because the dividend, well, dividend is degree of division 3, right? And the quotient, since what we divide the, let's say just you know, these are numbered, 217, what we got. Let's just say these are just coefficient of polynomial whose degree is 1 less than degree of dividend, okay? Mathematical, that's not the correct definition, but I think, yeah, let me just say that, okay? Because it works. So 217, these numbers, not only 217, but for any, whenever you just do a synthetic division, you're gonna get the numbers, okay, list of numbers. Definitely last number must be remainder always. But the list of numbers represent the coefficient of polynomial whose degree is 1 less than degree of dividend. Okay, since here the dividend is degree 3, right? Degree 3 polynomial, so this must be coefficient of degree 2 polynomial, which is 2x squared plus x plus 7. Okay, so this is a cube x quotient. Okay, so as you can see, that synthetic is a little bit abstract, but much less complicated than ordinary division, right? Okay, but there's pros and cons. Ordinary division and then synthetic division. Ordinary division, you can divide any polynomial by any polynomial. I mean, you can divide polynomial given by any polynomial, but synthetic division, you can apply this one for only problem dividing by the binomial. Okay, so what that means, so here given p of x, okay, let's say p of x is right there. If you want to divide by, for example, not just x minus 3, but what if it's just x squared plus x plus 7, okay? Then you can do this one using ordinary division. So p of x by x squared plus x plus 7. Okay, what about synthetic division? No, you cannot use synthetic division. Okay. So now, okay, once we got the ordinary division, synthetic division, let's see remainder theorems. Okay. So remainder theorem is this. Here, this is the remainder theorem. Remainder theorems. So once we okay, so p of x, we could express p of x in terms of divisors, dividend, and remainder, right? Say in general, let's say x minus c. Okay, q of x and then plus r. So divisor is x minus 3. Okay, this is divisor. Okay, this is quotient. Okay, this is remainder. Okay, then p of c is equal to r. That makes sense, right? That's the remainder theorem. So for example, back to the p of x in this example. Okay, so I want to find out p of 3. Okay, so here's the example. Okay, let's say p of x is defined by 2x cubed and then minus 5x squared plus 4x minus 6. Just this is what we just saw in the example right there. Okay, so then I want to find out p of 3. Yeah, simply just the substitute 3 into x in the polynomial function, and you can figure out the answer, right? But instead of that, we may find out p of 3 by using remainder theorems. So remainder theorem says that if p of x can be expressed as x minus c times q of x plus r, then p of c equals r. It makes sense, right? Because when x equals c, that divisor is going to be 0. 0 times q of 3, 0, 0 times q of 3 is 0, right? Plus remainder, so p of c turns out to be r. Now, how can you use remainder theorem? We divide p of x by x minus 3 using either ordinary division or syntactic division. Actually, we did that. So now then you got q of x. We already know what it is, q of x. And then plus remainder is what? 15, right? It turns out the remainder 15. So now then p of 3 is nothing but what? 15. Okay. All right. I know just, finding, just directly, plugging 3 into x, maybe that's a more easier than that way using the remainder theorem, but I want to explain how I want to just introduce how remainder theorem can be used. Okay, so when you find a p of 3, we divide the polynomial by x minus the number right here. Okay, so in the other question, when you find out p of 5, then what? We divide the polynomial function by x minus 5. You get q of x, and then you're going to get some remainder, right? Then just p of 5 must be r. Okay, so clear on this. That's remainder theorems. And then the factor theorem is this. Yeah, so you see, give me a second. So here's a slide. Yeah, let's see an example. Let's see. Yeah, 2. Okay, use the division to find the quotient and the remainder when x to the 4th power minus 14x squared plus 5x minus 9 is divided by x plus 4. Okay, but you could use this ordinary division, okay, instead of synthetic division. But all right, so um, then let's see. Okay, so let me just tweak the problems. Okay, so let's copy it. The problem example 2 in the textbook. So let's define p of x as x to the 4th power minus 14 x squared, and then plus 5x, and then minus 9. Okay, so let me tweak the problems. Use the remainder theorem to find the p of negative 4. Okay, so use the remainder theorem, okay, to find p of negative 4. Okay, give me a second. All right, so now to find out p of negative 4, I'm going to use the remainder theorem. It means that we got to divide p of x by x plus 4. Okay, so why x plus 4? Why divisor must be should be x plus 4? Because when you divide the p of x by x plus 4, then you can express p of x as like this: x plus 4 times q of x plus r. You see that x plus 4? It means that when x is negative 4, it means that when you evaluate p of x by p of x at x is negative 4, then divisor is going to be 0. So this is how to find out divisor when the problem asks you to find out, evaluate, p of a specific number using the remainder theorems. Keep in mind this. So this is going to be r, by the way, by the remainder theorems. So now I'll just use the division to divide the p of x by x plus 4. So it's 1. By the way, you see, the x cubed term is missing. Even though x cubed term is missing, when you use a syntactic division, you have to mention the coefficient term, a coefficient of the missing term. Okay, so x cubed is missing, but we have to put 0. Okay, so it's a negative 14, and then 5, and then negative 9, and there's 4, right? Because it went negative 4, yes. When x is a negative 4, because the divisor is going to be 0. Okay, copy down, negative 4, negative 4, 16, 2, negative 8, negative 3, 12, Okay, so let's see, 3 and then 3 right here. Okay, so this is remainder r. Then what's the cube of x? This is x cube. Why is x cube? Because see that degree of dividend is what, 4. That means these are what, coefficient of polynomial whose degree is 1 less than dividend, which is a cubic polynomial, right? So x cubed minus 4x squared plus 2x and then minus 3. Okay, so we got this we figure out q of x and the remainder, right? So by the remainder theorem, p of negative 4 is what, 3. Okay, so by the remainder theorem, p of negative 4 is equal to 3. Okay, so this is how to use remainder theorem. Okay, all right, the key mind is when you apply synthetic division, you see that you have to mention the coefficient, which is 0, of missing term. Okay, so now next one, the factor theorems. Let me see a slide. Okay, ooh, yeah, okay, so factor theorem is this, number c is a 0 of the polynomial function y is p of x if and only if x minus c is a factor of the polynomial. That's really obvious. Why? Because the remainder, I mean, the what? Number c is a 0 of the polynomial function. It means that p of c equals 0. Okay, so what that means? So let me remind of the meaning of 0. Okay, give me a second. You see that if y is a p of x is a polynomial function, then a value of x that satisfies p of x equals 0 is called 0. Okay, so what is 0? 0 is actual root of function, but we use the terminology 0 when the function type of function is polynomial. Okay, so polynomial function. So the factor theorems, if p of c equals 0, right? It means what? It means p of x can be expressed as x minus c times certain quotient function and then plus r, so that r must be 0. Otherwise, what? When you plug in c, we're not going to get 0. It makes sense, right? So, okay, you see, because just, substitute c into x. P of c is equal to c minus c times q of c. You see, c minus c times q of c is 0, right? The plus r. So, if r is 0, that means x minus c must be a factor. If r is not equal to 0, then x minus c cannot be a factor. Okay? So when you divide the polynomial by x minus c, and then you got the 0 as remainder, that means x minus c must be a factor. Okay? That factor theorem can be used to figure out whether or not x minus c is a factor or x minus c is a factor. So what that means, you see this example. So example 4, determine whether x plus 4 is a factor of the polynomial. You say, okay, how can you figure out that? Then you divide p of x by x plus 4. Okay, so and then remainder equals 0. Then by the factor theorems, the x plus 4 must be a factor. Okay, so let's do this. Let's solve example 4. So now then p of x is given by x cubed minus 13x, then plus 12. Okay. Let's see. Okay. Now let me use synthetic division. Okay, so there's a 1, 0, because we need to divide the p of x by x minus 1, x plus 4. We divide this p of x by x plus 4. Okay, so 1, 0, negative 13, and 12. Okay, so let's put the negative 4. Okay, it's a 1, negative 4, negative 4, 16, 3, and then negative 12, right? So it's a 0. So you see that remainder 0. This is a remainder r. It means that what? P of x. Now, since we divide the p of x by x plus 4, so p of x can be expressed as divisor x plus 4 times q of x, which is x minus 4x, x squared minus 4x plus 3, right? And then plus 0, right? So it means that by the factor theorem, this is what? A factor. The factor of p of x. Okay, because we got 0 as a remainder. Okay. So now next one is the fundamental theorem of algebra. So simply saying that the fundamental theorem of algebra, the simply saying that any polynomial function has at least one zero, okay, and that at most n zero. Here n is the degree of polynomial, okay, at least one and at most n zeros. Here, where n is the degree of polynomial. Keep in mind this. That's fundamental theorem of algebra. Okay, so for example, we saw that this problem. We see that this polynomial function p of x is equal to x cubed minus 13 plus 12. So how many zeros this polynomial function has? At most 3. At least 1 and at most 3. Okay. So somebody asks you that this function, polynomial function, has 5 zeros. You should answer that no. Okay. Why? Because of the fundamental theorem of algebra. Okay. So now next one is the the most important thing is this: the rational zero theorems. Now this looks like complicated. So let me rewrite this one. The using easy expression so that you can easily understand what it is, because this is really important. So rational zero theorem is this. So let's say p of x given, polynomial function is given, okay? So a x to the nth power plus through the constant term, okay, c, okay? So a is the leading coefficient. Okay, and then c is the constant. Okay, constant, right? And then I want to find out the rational zeros. Here, rational zeros means that we want to find out zeros that are rational numbers. Okay, maybe we're gonna get complex number. We're gonna get zeros that is complex number, but just we ignore that cases. Okay, but first we want to find the rational zeros. But how can I find the rational zeros? First, we want to find the possible rational zeros. Okay. So possible rational zeros. So really, what does that mean? Possible rational zeros. Literally, possible rational zero means that possibly, uh, these numbers could be zeros or no. We don't know unless we directly plug the number into the polynomial function to see the output is 0. If output is 0, yes, that number must be actual 0. Okay, so we just find out kind of is, we want to find out the set of the candidates who has potential to be a zero, actual zero. Okay, so this is equal to plus minus, not plus minus, let me put plus minus here, plus minus the set notation, okay, of that fraction. The top one must be a factors. Okay, see, a factors of constant term divided by factors of a leading coefficient. Okay, leading coefficient. Okay, keep in mind this. So this is the example. Let's see. Okay, so let's see example. The example, you try this problem in textbook. Let's say P of x is equal to x cubed minus 3x. Oh, not this one. Give me a second. So let me open textbook. Chapter 3, 3.2. Let's see. Okay. So P of 2, P of negative 1, 0 or not. Okay. Let's see. So now, and then P of 2 equals 0 or not. We have to using the calculator. Okay. So now then, let me see. Yeah, using the calculator, you figure out that. Okay. But let's see. I think I did this one before. Okay, to save time, let me just I did this one. So I figured out the number out of the possible ratio zeros, which is 1/2. Okay, so I think a p of 1/2 determines 0. Okay, we find this actual zeros. This is the true 0. Okay, so then what that means, we just got 1 0. Okay, the problem says that find all real and imaginary zeros. So you see that a degree of the f of x is what? 3. Then by the fundamental theorem of algebra, this guy has at most 3 what? 3 zeros. But we just got 1 0. It means that we have to find out 2 more zeros. Okay, how can I do that? We use the Orient division, synthetic division. It means this: we're gonna express p of x by divisor, dividend, a divisor, quotient, remainder. Okay, since p of 1/2 equals 0, it means that by the factor theorems, p of x can be expressed as x minus 1/2 times q of x, and then plus remainder r, and then r must be 0 by the factor theorem because 1/2 is 0. So then let's figure out q of x. So I'll using the synthetic division, I'm going to divide the p of x by x minus 1/2. So by the way, what's p of x? Yeah, sorry, I just used, let me say this is p, okay, p, okay. Then p of x is, dividend is this, 2x cubed minus 3x squared minus 11x plus 6. So it's going to be 2 minus 3 minus 11 and 6. Okay, 2, 1, negative 2, negative 1, negative 12, negative 6, and 0. So q of x is 2x squared minus 2x minus 12 Okay. All right. So this is a quadratic function. It's not a big deal to find out factors. I mean zeros of the q of x, right? So keep in mind, this goal is to find out all of zeros of p of x. Okay. So we got one zeros, which 1 0, which is one of zeros, which is 1/2, right? Because x is 1/2, x minus 1/2 gonna be 0, right? So that p of 1/2 gonna be 0. So then definitely remainder should be 0. I just confirmed that, right? I just verified that this is remainder 0, right? And then then what? We need to figure out the zeros in q of x. Okay, what number for x makes making the q of x 0? Then what? If the but fortunately in this case, since q of x is what? The quadratic function, I'm going to use quadratic formula to find out what? Zeros. Okay. Or you can, I think you can try to factor this one because 2 is a common factor. So we got x squared minus x minus 6. This is equal to 2 times x minus 3 times x plus 2. Okay. But yeah, so either one just fine. Just use a quadratic formula or just factor like this. Okay. And that's fine. So now then using the quadratic formula, then you're gonna get the same zeros. In this case, zeros is what? 3 and -2, right? When x is 3, x minus 3 is going to be 0. So that p of 3 is going to be 0. When x is -2, x plus 2 is going to be 0. It means that p of -2 equals 0. Okay, so finally we can express p of x as like this. X minus 1/2 times 2 times x minus 3 times x plus 2. Okay, in this problem, in this function, this p of x doesn't have I mean, all three zeros are real number, right? That guy doesn't have imaginary 0. Okay, right. So keep in mind this process. But one more things. What if q of x is not a quadratic function? Maybe cubic function, fourth degree 4 polynomial. Then you have to find the possible zeros of q of x. Okay, to find the actual 0. Okay, and then divide. I mean, it's literally just to repeat the process what we did here in this example. It means this. So here, when you find out how to find all real and imaginary zeros, step 1, okay, find all possible relation zeros. Okay, zeros. All right, so in the step 2, find a true 0 in the set of possible relation zeros. Okay, in the step 3, the find q of x. Okay, it means this. We will express p of x as like this. X minus c. Here, let's say c is d0. Okay, found in step 2. Okay, then we could express p of x as x minus c times q of x. The remainder must be 0, right? Because it turns out that c is a 0, actual 0. It means the remainder must be 0. 5 factor theorems. So then we figure out q of x. What? Using the what? Ordinary division or standard division? Or synthetic division. Okay. Now step 4. And then what? Repeat the process. Step 1 through the step 3. Okay. In Q of x, for the Q of x. Okay. Repeat the process step 1 3. So we're gonna find you find all possible rational zeros of Q of x, and then find true zero in the set of possible rational zero. Okay, I mean to find the true zero for Q of x, and then what? Express Q of x in terms of divisor and quotient. Okay, until we completely disassemble the Q of x. Okay, keep in mind this. All right. So now, until we repeat this one until we express P of x as like this, is equal to x minus c times x minus certain number, like this. Okay. So then c must be c is a 0, and then the box must be a 0, and then triangle must be a 0. Okay. Keep in mind this. So let me stop here. Okay, so definitely you need to practice. Look at the examples in textbook. Okay, so and then let's see.